Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to take a look at a Chapter 7 to 7.1 review sheet submitted by a student. We're looking at this from Algebra 1, the Algebra 1 textbook, and the Big Ideas textbook. There is a spiral review question from Chapter 6 on this review sheet. That's the very last chapter. That's the very last question. But mostly all of these are multiplying polynomials, adding polynomials. These are the questions that the student really had trouble with. There were other questions on this review sheet, but most of these are multiplying polynomials. Okay. So without further ado, for problems 1 and 2, we have to identify these 4 things. So let's get started. So the very first thing is when we write something in standard form, we want our leading coefficient, or our leading term, to be with the highest exponent. So in this particular case, this is my highest exponent, and I want to make sure that I include this positive in front of this exponent, in front of this term, because it shows that it's a positive 6, not a negative 6, okay? So I'm going to end up with 6x to the 5th minus x to the 4th minus 2. And all of my exponents are kind of going in descending order. It doesn't matter if my coefficients are going in descending order, the exponents are what's key, right? So now I've got 5, 4, and 1. The second thing is, what is the degree of the polynomial? The degree is always going to be the largest exponent. So this is going to be 5. What is the leading coefficient of this? The leading coefficient is going to be the very first number, and that's going to be 6. And then I need a constant. And so the constant is actually just the last number, or I guess not the last number, the number without a variable. And in this case, we also want to make sure that we're including whether it's positive or negative. So in this case, the constant is -2. Same principle here. We want the first term to be the largest exponent. So in our case, it's going to be 3, but in this case, it's actually negative. So we're going to have negative x to the 3rd plus 2x to the 2nd plus 7. My degree of this function of this polynomial is 3, because that's the largest exponent. My leading coefficient is going to be -1. And then my constant is going to be 7. And again, we know that this is going to be the number without a variable, that's the constant, and the coefficient is always the number in front of this first term. And here there's this invisible 1. Okay, so now our job is to go in and multiply all of these to do some sort of either FOIL or multiple distribution, or you could also do what I like to call an area model. I think it's super helpful, especially when we get to problems later on in this particular review sheet. If you feel that FOIL is a super helpful method, so FOIL actually stands for first, outer, I don't think I'm spelling that right. That also does not look right. Inner and last. Okay, so what happens is we're going to multiply the first terms, we're going to multiply the outer terms, we're going to multiply the 2 inner terms, whoops, and then we're going to multiply the last terms. So x times x is x squared, x times -5 is -5x, 2 times x is plus 2x, and then 2 times -5 is -10. We can tell that these 2 terms are like terms, so we can go in and we can say x squared minus 3x minus 10. And since I can't combine any other terms, I would say that that would be my final answer. Again, I'm going to do the same thing, except I'm going to do it a little bit differently, because I'm going to put my arrow or put my little half circle or half oval, and actually do the multiplication. So 3n times 3n is 9n squared. 3n times 4 is going to be 12n. Then -1 times 3n is -3n. and negative 1 times 4 is negative 4. Again, we have very similar terms here. So I'm going to end up with 9n squared plus 9n minus 4. And then I can't simplify anymore because I don't have any more like terms. I would recommend trying the next problem on your own before watching me solve it to see if you are understanding the concept at this point. Okay. So again, we could do this method, which is the area model, but I will save it for the next slide. So 2m times m is 2m squared. 2m times negative 1 is a negative 2m. 1 times m is positive 1m. 1 times negative 1 is negative 1. Again, I have these two that are like terms. Now, something that most students will forget to do is they might forget to combine these two. That could be an issue. Another thing that could be an issue is forgetting a negative or positive sign. So for example, instead of writing negative 2m here, you're writing positive 2m. That'll change your answer from minus m to plus 3m. So we're looking at slightly different small mistakes. I don't know that a lot of students tend to make these as large conceptual errors. Okay. This problem, on the other hand, is actually a little different, and I'm going to put it in a different color specifically because of this 2 out here. The mistake that most students see is they see a squared and they kind of go in and they say, oh, I'm just going to apply this to both of these, kind of like distributive property, but not exactly, right? And so the issue with that is that because it's not distributive property, we can't simply just, hey, I'm going to distribute this squared. That squared actually means that there is one parenthesis of 2a minus 5 and another parenthesis of this 2a minus 5. So we're looking at two of exactly the same parentheses for us to be able to complete this FOIL problem. So I've got 2a squared, 2a times 2a, which is going to be 4a squared. 2a times negative 5 is going to be negative 10a. Then I have negative 5 times 2a is negative 10a. And negative 5 times negative 5 is actually positive 25. So you want to make sure that you don't leave that as negative 5. That's been another error that most students have made in the past that I've noticed. Also, you'll notice that these two are actually the exact same number because we're multiplying the exact same terms in order to get that inner and outer portion of our foiling, right? So we want to just take that and double it. So we're going to do negative 20a plus 25, and that's going to be my final answer here, okay? When we take a look at this, we could also follow the pattern of, I'm going to take the first term, square it, so 2a squared. I'm going to take double the first term multiplied by the second term. And then I'm going to take the last term, also squared. So you'll see that 2a squared is actually 4a squared, negative 5 squared is positive 25 or plus 25. And then this 2a times negative 5 is negative 10a. Double that is negative 20a. There is that pattern, there is that formula that you can memorize, but if you understand the general concept of how to FOIL, you should be able to understand how to solve all of these problems. I would just recommend this 2 being a little bit more focused on as a square, so showing that set of parentheses twice. Oh, there is nothing on this slide. Here we go. Moving on to the next slide. I wonder if I just totally skipped a whole slide. Good job, me. Okay, so this is also a very similar concept as this last one, where I have this x plus 9 times another x plus 9. So I know x times x is going to be x squared. Then I have 9 times 9, I know is going to be 81. So I'm just going to show you how this is going to look. This inner 9 times x, and this outer 9 times x is going to be double 9 times x, so 9x plus another 9x, which is basically going to be twice 9x, which is going to be x squared plus 18x plus 81. Again, if this is not your comfort zone, you can definitely go in and just continue doing the FOIL like you have been all the way through. In this particular case, we can tell that I have two of almost exactly the same sets of parentheses, except this one has a negative and this one has a positive. So I've got what's called the difference of two squares. So this difference of two squares is, let me double check this. Okay, here we go. Difference of two squares is when I have the first and second term are the same in both sets of parentheses. And the only change in between those two sets of parentheses is one has a plus and one has a minus in between the two terms. So I know, for example, that this right away, because I know the formula for difference of two squares, is going to be this 3x squared and this 2 squared, and there's going to be a subtraction in the middle. However, I do want to show you how this also looks when we are going to distribute fully using FOIL. So let's finish this problem off actually. So we're going to end up with 9x squared minus 4. So this would be my final answer, knowing this formula of the difference of two squares. However, if we do 3x times 3x, we're going to get 9x squared. 3x times 2, we're going to get plus 6x. Negative 2 times 3x is negative 6x. And negative 2 times positive 2 is negative 4. You'll notice that these two are exactly the same terms, except one is plus and one is minus. So we can get rid of them, making our answer 9x squared minus 4. So exactly where I started off originally. Now, this next one is also a little bit different. So I'm going to do a different color to show you how I would solve this. And I would not recommend solving using FOIL in this particular case, only because there's 3 terms and it's going to get a little crazy with my arrows. So in here, I would do what's called an area model. So when I create a box, here we go. This might be big enough. And then I'm going to split it up into 3 sections. Ooh, this is not quite the best. Whoops. Okay, and then we'll move you, and then, okay, we'll move you. All right, here we go, here we go. Last line, and we're gonna move this line a little bit here. There we go. So I would draw a box that has 3 terms on top and 2 terms on bottom, only because if I draw it the other way with 3 terms on here and 2 terms on here, it's going to get a little bit smushed in my space. But if you have a paper, it doesn't matter. If you have plenty of space, it doesn't matter how you draw it. So I'm going to put 3b and minus 4 here, and then negative 2b to the third plus 4b squared minus 10. This does a really great job organizing my thoughts in clear, concise places. So what I'm going to do is I'm going to take 3b and multiply it by each of these terms so that they will each have an answer in these boxes. And the reason why this is called the area model is because when we find the area of a box, we do base times height or length times width, right? So when we do that, this is my height, this is my base, or this is my length and this is my width, right? So I'm going to go in and multiply this to find the inside, and I'm going to actually put the inside as my answer. So this will be negative 6b to the fourth. 3b times 4b squared is going to be 12b to the third. 3b times negative 10 is negative 30b. I'm going to do the same exact thing with this negative 4 and all of these numbers. So this will be positive 8b to the third negative 16b to the second, and positive 40. Um, then the other thing that I can do is I can actually see that I have similar terms, right? So this and this is a similar term, and I can go in and bring them together. So my final answer for this would be in order of largest exponent first, and then all the exponents going down, down, down. So I'm going to end up with negative 6b to the fourth. These two I would add and get 20b to the third. Then I would put the second exponent, so negative 16b to the second minus 30b plus 40. And again, this would be my final answer in standard form, largest exponent first, going all the way down until I have no more exponents. There are multiple ways to solve this problem. I think this would be the most direct method possible so that we can actually see what's going on. Okay, let's take a look at the next one. So for example, in this type of problem, even though there's still a lot going on, there's only one number that we're going to go in and we're going to multiply by every other number. So I would say this is totally fine to do kind of like a FOIL method where we are just distributing this x squared to every single one of these terms, okay? The possible mistake that I see that students might make with this is forgetting that you have to add the exponents. Another thing that I could see, for example, is if the answer needs to be in standard form. This problem is not in standard form because I have x to the third, x to the first, and then x to the second. So maybe we might have to change that later. Other than those two things, I don't think that there's a lot going on with errors. Okay. So x squared times x to the third is going to be x to the fifth because I'm just going to add those exponents. So I'm going to end up with negative 5x to the fifth. Then x to the second times x to the first is x to the third. So negative 11x to the third. X to the second times x to the second is x to the fourth. So minus 7x to the fourth. And then plus 2x squared because there's no variables here. So I don't even have to worry about it. I would flip-flop these two. Again, if this was a plus, I would actually take this whole thing and this whole thing, and I would flip-flop both of them. So I'd have negative 5x to the fifth minus 7x to the fourth minus 11x to the third plus 2x squared, so that we can see that we have our exponents in standard form, starting with the largest first, moving all the way to the smallest. This problem is interesting for many reasons. I would say this is more of an Algebra 2 problem. My opinion is students on an Algebra 1 level should know this type of problem, should know even maybe a two-term expression times a three-term expression, so a binomial times a trinomial. But a trinomial times a trinomial, there's just a lot of room for error. So in this particular case, I would say, let's go in and let's make a box. And I would make a 3x3 box in order to really see and organize my thoughts. So I'm going to have one here and one here. I might even just move this up a little bit more so that I have some more space. And then I've got one here and one here. Okay, and then I'm gonna put up here, and I can put x squared minus 2x plus 8 over here, or I can put it over here. It doesn't matter how you decide to label it. The only thing that I would recommend is putting in the positives and negatives in the right places so that you know what's happening. And then we just go in and we straight up multiply, right? So we end up with negative x to the fourth, positive 2x to the third, negative 8x squared. Every single time I'm multiplying these two, these two, these two. And this is kind of like that same business that I have with my blue arrows. If I were to show this using kind of FOIL, it would be these three right here. When I go in to multiply this 3x, I would go in and I would go here, here, and here, another set of arrows. And you can tell already it's starting to get a little bit messy. I know I don't have a lot of room on top, but even if you do have a lot of room on your piece of paper, it is kind of a little bit not the best method. So then I'm going to go in 3x times this 2x squared times this x squared. So I would get 3x. Whoops, I did not want this color. Okay, this would be 3x to the third, negative 6x squared, and then plus 24x. Here I would just multiply by negative 4, so my x's would stay the same, but my variables my variables would stay the same with the actual terms, but my coefficients would change. Okay, now what I notice in here is that I actually have these two terms are the same. I also notice that these two terms are the same. And I also notice that these two terms are the same. So this is a really nice way to organize your thoughts and to really get these thoughts kind of in one particular place so that you're not wibble wobbling all over the place with a million different terms, right? Because then you would have 9 terms in one long line and it'd be kind of harder to see all of those like terms. So then my final answer for this would be negative x to the fourth. I would add these two and get plus 5x to the third. I would add these three and get negative 10, negative 18. X to the second, this would be plus 32x and then minus 32. Okay, here we go. And that would be the final answer, again, from largest exponent all the way to the smallest exponent until we have a constant. Putting it in standard form is pretty important. Okay, so this is the review question that I see on this assessment, or on, not assessment, on this like prep for assessments, right? So this review sheet. My assumption is that there are some spiral review questions on most homework assignments, and I hope that there are, only because you need to know the previous math in order to get better at the current math, right? And you never know when these things will show up. So my recommendation is to actually take this entire problem and kind of like elongate it and separate it so that you see things a little bit differently. So I'm going to put 15 and 3 to the negative second on top of each other because those are actual numbers. I know my next term is a to the 7th. My next term is b, and I'm just going to go in order, right, of a, b, c. And then I'm going to go in and I'm going to solve this particular thing. So I know I'm going to start with the easiest thing first. Anything to the 0 power is 1, so I don't even need to see it. Anything with a negative exponent like these three are going to end up in a different place in my fraction. So when I look at this once more, I'm going to end up with 15 times 3 to the second. A to the 7th is going to go up top, and b to the 5th is going to go down below. There's nothing else that I can actually go in and simplify. So I'm just going to go ahead and multiply everything and put it all into one thing. So this would be 15 times 9, which is 90 and 40, 135. A to the 7th over b to the 5th. Because I cannot simplify anything anymore, this is my final answer. I hope that this was helpful, and I will see you in another video. Bye.